Hello everyone. You are watching another episode of Military TV. Why the Air Force's F-16 is still a deadly plane. The General Dynamics F-16 Fighting Falcon is a single-engine multirole fighter aircraft originally developed by General Dynamics for the United States Air Force. Designed as an air superiority day fighter, it evolved into a successful all-weather multirole aircraft. It is one of the only top jet fighters in the world to also be cost-efficient. This light fighter jet is fast and extremely agile, and it remains the most popular aircraft in modern military duty, with almost 2,700 in service around 26 countries out of a total production of 4,500. Needless to say, the 1980s cutting-edge fourth-generation fighter will be with us for a long time. The F-16 was designed in response to a dilemma faced by the Air Force during the Vietnam War, in which the fast and heavy F-4 Phantom fighters underperformed against the North Vietnamese Air Force due to inadequate long-range missile capability and a lack of precision maneuvering in dogfights. This prompted the fighter mafia to claim that the Air Force's design priorities were incorrect, and instead of another heavy twin-engine fighter, what was truly needed was a reasonably cheap, lightweight airframe that optimized energy for short-range dogfights. The F-16 Fighting Falcon was built under an unusual agreement, creating a consortium between the United States and 4 NATO countries: Belgium, Denmark, the Netherlands, and Norway. The consortium's F-16s are assembled from components manufactured in all 5 countries. Recently, Portugal also joined the consortium. This program improves the F-16's combat readiness by increasing the supply and availability of repair components in Europe. So, why the F-16 Fighter Falcon is still a deadly plane? All of F-16 light fighters, which delivered since November 1981, have built-in structural and wiring provisions, as well as systems architecture that allow expansion of the multirole flexibility to perform precision strike, night attack, and beyond visual range interception missions. This upgraded program led to the F-16C and F-16D aircraft, which are the single and two-place counterparts to the F-16A or B, and incorporate the latest cockpit control and display technology. All active units and many Air National Guard and Air Force Reserve units have converted to the F-16C or D. Moreover, the single-engine F-16 used new design technologies to maximize kinematic performance. For instance, a powerful Pratt & Whitney F-100 engine with the intake slung under the fuselage could create an excellent thrust-to-weight ratio due to the overall lightness of the Falcon, pushing the F-16 to twice the speed of sound at high altitude. In addition, to support the cropped delta wings, pronounced strakes bulged out from the fuselage like the hood of a Cobra, allowing for extremely high roll rates. A bulging bubble canopy also afforded an excellent field of view for the pilot, who was lounged in a seat angled 30 degrees back so as to mitigate the G-forces from violent maneuvers. Furthermore, the F-16 also could pull off very violent maneuvers indeed, becoming the first jet fighter able to pull 9 Gs in a turn, tighter than any other U.S. fighter until the advent of the F-22 Raptor. In fact, to maximize its maneuverability, the F-16 was intentionally designed to be aerodynamically unstable, a deficit which its flight control system automatically compensated for. This was possible because to the F-16's groundbreaking fly-by-wire control system, which essentially meant that the pilot's commands were interpreted through an electronic interface rather than hydraulic or cable-connected manual controls. Fly-by-wire controls were not only more dependable, but they also allowed the flight computer to modify the pilot's maneuvers as needed to stay within the Falcon's tolerances. Another feature was an integrated throttle in the joystick, known as hands-on throttle and stick or HOTUS, enabling much smoother operation by the pilot. Fly-by-wire and HOTUS have since become standard features in modern combat aircraft. However, unlike the early model F-14 and F-15, the Falcon was also designed as a multirole fighter, and it could lug up to 17,000 pounds of munitions or electronic warfare gear on its 11 hardpoints, including a new generation of precision-guided weapons, such as Maverick missiles and laser-guided bombs, and also a 20mm Vulcan cannon in the lower fuselage served as a backup weapon. Ironically, while the fighter mafia placed little faith in guided missile technology, the F-16 arrived at a time when they had reached a new level of efficiency, with the Falcon's APG-66 Doppler radar, heads-up display, and targeting computers were able to leverage these weapons to deadly effect. This was demonstrated in 1991, where USAF F-16 multirole fighters were deployed to the Persian Gulf in support of Operation Desert Storm, where more sorties were flown than with any other aircraft. These fighters were used to attack airfields, military production facilities, Scud missile sites, and a variety of other targets. Since the Gulf War, the Falcon has been a mainstay in U.S. and NATO air campaigns over the former Yugoslavia, Iraq, and Syria. Moreover, American and Belgian F-16s also shot down additional enemy fighters over Serbia and Kosovo during the 1990s, though 2 were brought down by Serb surface-to-air missiles. Furthermore, the F-16s sold abroad have also seen action in numerous of conflicts. For instance, Pakistani F-16s shot down 10 Soviet and Afghan aircraft on its border during the 1980s. In 1992, 2 Venezuelan Falcons pilots played a key role in defeating a coup by supporters of Hugo Chavez by shooting down 2 rebel OV-10 Broncos and a Tucano trainer. Interestingly, by one count, the Falcon has shot down 76 enemy aircraft, while only suffering 1 or 2 losses in aerial combat, generally under ambiguous circumstances. And of course, Falcons have continued to serve as bomb-toting workhorses for airstrikes on targets in Lebanon, Iraq, Libya, Syria, Afghanistan, and Pakistan. Lastly, for the upgraded F-16s, they are equipped with conformal fuel tanks that considerably expand the Falcon's limited range while reducing aerodynamic drag, as well as an APG-80 active electronically scanned array, or ESA radar, which represent the cutting edge of fighter-borne radar technology, due to their better resolution and reduced visibility to opponent radars. Currently, a more advanced Block 70 variant is being considered for production in India. However, the prices for these newer Falcons have risen dramatically. In addition, due to delays and cost overruns in the F-35 stealth fighter program, the U.S. Air Force plans to keep flying its 1,200 F-16s long into the 2040s by extending the airframe's service life from 8 to 12,000 hours. The Fighting Falcon has proven to be a capable and flexible combat jet, and furthermore, it costs $22,000 per flight hour to operate, compared to $42,000 for a twin-engine F-15. Anyway, if you like this video, don't forget to hit the subscribe button for more updates on awesome videos. That's all for today. Thanks for watching.